Good morning, good afternoon to all the participants, and very warm welcome to our speaker of the today's webinar, Professor Dr. Attila Nagy from Hungary. And as you all know that ICID started this webinar series on smart irrigation management in October 2025. And so far we had six webinars, and today's webinar is the seventh webinar in the series. And this webinar has been taken very well by our participants, and we are getting very good feedback, considering that it's a very important subject of in today's water resource scenario, when everybody is facing water scarcity and due to climate change, we have food and water scarcity everywhere. And in this scenario, we know the role of smart irrigation management, which can save a lot of water, which is very, very precious for all. And especially when we know that about 70 to 80% of water is being used for agricultural water management. So any saving in agricultural water management goes towards the fulfillment of our goal of water uh, security for all. So this smart irrigation management, of course, is striving on uh, uh, automatic collection of data, weather data, soil data from sensors, and working on automatic controls of water. And it is giving water to the plants to when and where it is needed. So that is the motive of smart irrigation management. And it's a proven technology, and with many, many different kinds of technologies, it can save around 50 to 70% of water, and wastage is reduced and crop yield is increased. This is a proven, we have proven case studies, and in our past webinars, we have seen that in many case studies, we are able to save 50 to 60% of water. Wasting of water is reduced, and crop yield is increased. So today we have at the webinar, the title is Precision Water Resource Management in Irrigation, Intelligent Sensing and Modeling. As I told you that it will be delivered by Professor Dr. Attila Nagy, and let I will give a brief introduction of Professor Nagy. He is a full-time professor and head of Institute of Water and Environmental Management, University of Debrecen in Hungary, Faculty of Agriculture and Food Sciences and Environmental Management. His research basically focuses on territorial water management and precision irrigation. He's a very recognized professor, internationally, nationally recognized professor in the field of non-invasive assessment methods for critical factors of water balance in agricultural water management, as well as in methodological and technical innovations in precision irrigation technologies. His key achievements are related to irrigation, agricultural water management, basically focuses on design and development of water balance monitoring systems, advancements in precision irrigation technology, and other technological improvements aimed at enhancing water quality and developing nature-based solutions. So he is a very recognized professor, and I welcome Professor Nagy for this seminar. And before I give the floor to you, I have a request from all the participants that if you have any question, please write that question in the chat box or question answer chat box. And I will request Professor Nagy also that at the end of the presentation, if possible, try to answer these questions by reading the question first and then answering them one by one, if possible, if the time permits. And please give your email at the end of the presentation, so that if any participant wants to have a specific question from you, he can write an email to you and he will interact with you. So before we go further, I would like to share that next month in June, we will not have webinar. We have a conference in New Delhi. It's a Indo-Global Irrigation Summit. We are organizing on 24th and 25th of June. 24th June is the foundation day of ICID. So in that, to celebrate that foundation day, we are organizing 2-day irrigation summit. And the theme of the irrigation summit is, of course, the same, smart irrigation management. So after this conference in July 2026, we will have our 8th webinar in this series. And this will be delivered by Mr. Abdul Hakim from National Remote Sensing Agency, India. And the title of the webinar will be From Satellite-Based Irrigation Monitoring to AI-Driven Irrigation Intelligence. We are not able to upload the flyer. So this is the flyer for the next webinar. This will be held in July on 24th of July. So I request all the participants to join the Indo-Global Irrigation Summit in New Delhi in June. And of course, the 8th webinar in July on 24th of July. So now I request Professor Nagy to present his presentation. And Professor, the floor is yours. Am I audible, Professor?
Yeah.
So now the
welcome everybody, and many thanks for the opportunity to keep presentation at this webinar. And I'm just sharing my screen. And can you see?
It is visible.
Oh, okay, it's visible. Okay, so my presentation will be about precision water resource management, and with special focus on intelligent sensing, sensoring, and of course modeling aspects. And here in this some 40-50 minutes, I will be focusing on the let's say the Pannonia region, Carpathian Basin, Tisza River Basin, and their problems about drought, and I would like to highlight some findings and research fields that we are working on, just in order to give you an insight how we are trying to manage our situation, our worse and worse situation in concerning the drought and the drought circumstances. So first, I would like to introduce where I am, let's say, and where is the field and examples and case studies that are coming from. So This region where I am working for is situated at the Danube River basin. It is quite big, and it is, let's say, controlled and organized by many countries. And of course, all of these organization was just under the umbrella of the ICPDR, the International Commission for the Protection of the Danube River Basin. And this river basin has of course special hydrological circumstances, because flood, drought, and even excess water in many cases appears regularly and often in the same year. So, for instance, last year or the year before, we have very serious drought circumstances. I mean, in general, in this Danube region, but in the this was in the summer period, but in the autumn period, we had record flood phenomenon as well. Of course, as every river, Danube River also have several tributaries, and Tisa River basin is one of the largest tributary of, river basin or sub-basin of the Danube River basin. And this sub-basin is situated here, as you can see, that 5 countries shares this river basin, and quite large, or almost half, is situated here in my country, in Hungary. And in Hungary, the whole country itself, but with special regard to this river basin, is a flat country. The Hungarian Great Plain is situated here. And one of the most important hydraulic characteristics of this Great Plain is that drought appears regularly in every third year at least, but you will see that in the previous 10, 20 years, the frequency of drought is becoming more and more frequent and more severe here in this small region. It is also important that especially in the past, Hungary often faced with excess water, inland excess water, due to surplus water circumstances, especially at the end of winter time and at the end of at the beginning of the spring period. But since 2018, there is no excess water, or there was no excess water here in this watershed and sub-watershed. So water resources are also shrinking here. And the right-hand side, you can see the drought zones. I think it is obvious that our Great Plain area is hardly affected. If I would like to present some facts related to drought conditions, I would say that in the past 5 years, we are suffering a continuous drought phenomenon, which means that since 2021, we had only 1 year, which can be stated as normal, not wet year, but with normal precipitation characteristics. So here in the middle, you can see that the cumulative deficit of the precipitation at this moment is almost the annual precipitation in Hungary. Of course, if we have a look at the long term, very, very long term, so more than 100 years of data, we can say that in Hungary, the amount of the precipitation is not decreasing. However, the days with rain is decreasing. So the extremities and extreme precipitation phenomena are also becoming more and more frequent. And of course, not just the temporal, but also the spatial distribution of the precipitation is changing. So more precipitation was standing or trending in the winter period and less in the vegetation period, which should be the most important from agricultural aspect. So on the other hand, we are suffering multi-annual drought at this moment. However, it seems in long term precipitation is not changing so intensively. On the other hand, if you have a look at here on the middle bottom with the warmest years since the last century, you can see that our climate is warming very intensively, and usually scientists are also saying that Europe is one of the spots of the Earth which is boiling up the most within this climate change. And here on the right-hand side, you can also see the more frequent drought conditions in the previous some decades. And as it is also obvious that within this climate change, not only warming, but the increasing of extremities are also present. So there you can see, if we have a look at the surface water bodies, flood records and also low flow records are also increasing in the were also increasing in the previous 20 years compared to the 70s and 80s in the previous century. So we are facing a problem which is driven mostly by the heat and increased evapotranspiration, which led to a significant decrease in underground water bodies as well. You can see two regions here in Hungary with red, and those are the deficit in cubic kilometers, which are missing already from the underground water bodies. So the water table is shrinking quite intensively, especially in the previous 1.5, 3 decades. So these are our facts and how these facts are affecting the agriculture. Of course, we have, or it is quite challenging, let's say, because I mentioned the problem of drought and their significant effect, not only in agriculture, of course, but due to food security and hydrological aspects. It has an effect on the society and environment, especially as well. Just a brief example for you. Maybe if I have a look at 10 years ago, our two main crops was winter wheat and corn. Both were grown around 1.2 million hectares. In this year, the sowing area of corn decreased below 7,000 hectares just because it's impossible to grow rentably, to profitably this plant, because we cannot grow it in many places and many sites here in the Hungarian Great Plain. So we have these challenges. On the right-hand side, you can see what I already mentioned, but these are predictions at this moment, not the past trends. These are predictions. As you can see, the precipitation will be around the same. Of course, spatial and temporal with spatial and temporal changes, temperature will increase, and eventually, somewhere at the end of the century, the potential of evapotranspiration will increase more than 20%. On the other hand, we have very limited water resources, especially here in this Tisza basin. This is one point, is because of the climate change. The other point is that we are, let's say, the low stream country or midstream country, so we have international yes, our waters are mainly coming from abroad, and of course their water retention is very significant and significantly affecting our water resources. And of course, based on these trends, there is an increased need for irrigation, but we won't have more irrigation water, and it's foreseen to have even less. However, in Hungary, the area that can be irrigated is around 250,000 hectares. So not that much. It is even 2% of the agricultural sites here in this country. And usually only half of this area is irrigated. The reason for this is the technological drawbacks, because in the previous 2 or 3 decades, there was no funds or not enough funds to do this. But in the previous some years, the government recognized this. So maybe the irrigation will also be developed, but in reasonable aspects, cannot be expected to grow more than 3 or 3.5%. So what we can do, of course, irrigation, water retention, using alternative water resources for irrigation. It is very important, and I will give you an example for this. Agroecological transition, and of course the soil-related aspects. So good agricultural practices in dry farming in order to capture and retain the water back on the fields. And of course, all of these requires monitoring with good sensing techniques, and of course, very good models in order to use efficiently our available water resources, either from the point of water governance or to the water allocation by irrigation on field using variable irrigation as well. And this is what I already talked about. So Hungary is trying to increase their potential in irrigation. But when somebody is irrigating, need to consider that irrigation is not just about water input. The farmer has to arrange the whole agri-technological system to this irrigated farming. Let me briefly introduce a little bit about my institute, because I think you should see all the sensor field, let's say, or sensor part that we have to do these researches and results. There you can see that we both have, let's say, laboratory scale and field scale infrastructure, both for hydraulic measurements, for infiltration, for channel modeling, but we also have the soil physical laboratory which we can measure everything. I mean, hydraulic conductivity, PF curves, and so on. And our institute also related to environment, so we have analytical laboratory as well, but it's more related to environmental problems. But here what you can see is mainly the field equipments with which we're making our researches, and you will see some results in the following some minutes soon. We have a very good geodesy tool park with ground penetrating radar as well. We have drone parks with LiDAR, thermocamera, multispectral, and even hyperspectral cameras, just in order to monitor the vegetation so as to have information about the vigor, which are, of course, representing either the nutrient or the water supply of the site, which can easily be, or these data can easily be integrated into the ETC, so crop evapotranspiration calculations, which can also be integrated in the modeling of the soil moisture dynamics, which can also lead or can be an input for prescription maps, for instance, in variable rate irrigation. Certainly, you can see some other equipments like core ones here, with which we can measure the transpiration, and this LI 710, the evapotranspiration of a plant or a field. And we also have agrometeorological stations, soil moisture sensors, and USVs for reservoirs, because at the end of my presentation I will also put some focus on reservoirs, because reservoirs are required in irrigation, because sometimes when we need the irrigation, water resources are very small, so we need to collect the water resource for irrigation in the non-vegetative period, so in winter time or spring. I put this here as a, let's say, summary of the precision irrigation, what is needed for this. Of course, agroecological aspects, as in normal case, let's say, so physical, chemical characteristics, nutrients, but don't forget about the crop type, of course, and all the machineries. And as I mentioned you, when we're talking about irrigation in general, everything has to be adjusted in accordance to this, even the harvest or plant protection. And of course, there you can see the irrigation technology and especially irrigation scheduling, which is also very important. How much water we need to utilize, where and when. So all of these things has to be well defined. And of course, the remote sensing and GIS and all the sensoring and modeling conditions that are here in the upper left corner. So soil sensors, agrometeorological data, raster data from aerial drone images, or even satellites, vector data collection, laser points, And of course, the decision support should be, let's say, one of the end product of this precision irrigation practice. The case study site where we are working a lot is just developed maybe 9 years ago. And one of the most important advantage of this site is that it is using alternative water resource. Says why? Because they don't have surface water resources, and underground water bodies are just not allowed to use here for irrigation because it is fragile and shrinking. And this was the reason why this farmer decided to utilize the other alternative resources, and my institute helped him from the very beginning to plan this irrigation and what type of irrigation machine should be appropriate for here. So they are utilizing excess water. They have some excess water collection ponds. And as you can see here, quite a lot fermentation sludge is produced because they have biogas power plants over there. So 500 cubic meter per day is quite a large amount. And they are utilizing the treated wastewater, which is coming from a nearby city. And at this moment, since they have they built several other reservoirs, they can collect around 1 million cubic meter water in the non-vegetation period, and they can irrigate their 800 hectares, which is very important. Here at this specific figure, there you can see this oval-shaped area. This was the place of the lateral or pivoting and lateral moving variable rate irrigation system, which was just developed here at this site. The unique in this that it can work both in pivoting and both in lateral moving mode. Therefore, there you can see here that more than 100 nozzles were set there, and 62 nozzles works in lateral mode, and the rest is in pivoting mode. And in this way, they can irrigate more than 80 hectare, handling 17 irrigation zones only in lateral moving conditions, joining 3 or 4 nozzles together. And what is also unique in this, although it is not written here, that proximal sensors, opt-RX sensor was also set along with the irrigation machine, with which are facing in front, and with which they can, in parallel with the irrigation or in another round, they can survey their plants, which is usually corn. They can collect NDVI data with this opt-RX sensor, and they can analyze the pattern of the biomass underneath the irrigation machine. Of course, when the machinery itself was developed by, of course, a company, an international company which works with this, but we also analyzed its accuracy or uniformity here in the site, and we found very good Christiansen uniformity factors. So we also, let's say, validated that. Just in order to schedule this irrigation system in a good way, we decided to build a model which is based on data, some modelings, and there can be several solutions. And of course, this idea was built on our previous data modeling and solution structures. So here I put all these, let's say, findings that we were working in the previous 1.5 to 2 decades. So we collect agrometeorological data, digital elevation models, soil data, and of course, in situ physiological data and remote sensing, which can be sentinel or drone data. And we put this, or we integrated this together in some, of course, the agrometeorological in CropVat, PenMan, integrating soil data for hydros or CLM community, and even in this hydros we integrated the remote sensing based ETC models, and our solutions are drought monitoring system, which is we have regional and field scale one as well, remote sensing based ETC models, soil moisture models, irrigation optimizing, and variable rate irrigation maps. Of course, we based a huge database structure in order to how to say, deal with or get along with all the data. This is just a segment of it, just to show you that geodatabase was generated. And then, based on these geodatabases, we used to generate some results. Here you can see yield estimation based on, this is based on MODIS sensor, and these are regional scale. There you can see one of our counties with the same legends for NDVI for wet year, dry year. So you can see, and these are arable lands. You can see the differences. We also analyzed irrigated and unirrigated maize. And of course, the basis is that the more dry is the area, the lower will be the biomass, which can be identified by the NDVI. And here you can see the sensor of OptRx that is just mounted on the irrigation machine. What was the most important result of this yield estimation? It was that we developed an early warning system based on this, and we found that both in the case, or either in the case of wheat and winter wheat and corn, we can estimate the yield loss itself. In the case of wheat, 4 or 5 years before harvest, and in the case of maize, 6-8 weeks before. It is very important because we checked the prices, and generally the grain prices are following or changing right after the harvest period. So even farmer or even decision maker can know how big should be or will be the yield loss and how it will affect the prices and the economy. So this is the regional scale. On field scale, based on Lancet and of course Sentinel, we developed other NDVI-based model. There you can see some root mean square errors as well related to this, just to show you the accuracy. In general, I would say that these models are underestimating in a case of high biomass more than in the case of low biomass. And we also tested thermographic surveys in the case of apple plantations using the crop water stress index. And of course, we also found that this index is very good. It can be a very good indicator as well to survey the moisture content, because the soil moisture, where the soil moisture was lower, this index was also higher. Anyway, these results then, I mean, yes, the methodology of these results then led to test or to develop vegetation index-based ETC model, where the concept was to describe the KC in a better way than this trapezoid shape, which can be found in the FAO 55 paper. Therefore, we tested beside the NDVI several other indexes as well to develop, let's say, a quasi-real-time KC value, which can be used to modify the crop, the reference crop evapotranspiration, which of course is calculated based on those parameters which are measured by the agrometeorological stations. So there you can see that these vegetation indexes can give us good results. These results was developed with an Italian partner as well, based not only on Hungarian pilot side, but on Italian one as well. If you have a look at the practical application of this on our Hungarian pilot site, there you can see that we can estimate the water balance of this corn area. On the left, you can see it in June, the cornfield, and in August, where it is clearly visible where the irrigation machine was walking back and forth, or not back and forth, sorry, around. Of course, you can see here some red spots, which were the problem of this irrigation channel, because this irrigation channel was in the springtime was or floods these areas, and of course there were no plants later, or at the beginning just some weeds, but later nothing. And after that, we also integrated this VI based ETC method into the Hydrus model, this physical-based model, where the soil physical parameters are one of the input parameters, and we try to model the moisture content of different years, and based on this integration at this site, we also identified, let's say, a real or an irrigation scheduling based on the real demands. Here you can see 2020 and 2021, and the 2021 is, let's say, what was the real testing period where the irrigation machine was just utilized in accordance with this modeling. And of course, using not only the biomass, but also the dimensional soil environment that we have developed. We were also able to provide prescription maps for this pivoting lateral moving irrigation system, but also, as I mentioned, only for the lateral aspects. Later, we also integrated the drone data. Here in the middle, you can see the soil sensors, which were just set and used either in Hydrus as real-time data for model building. But here on the left-hand side, you can see some results which are soil moisture estimation results using Sentinel-1, so the SAR, the radar data, and the calibration and validation of these data with real soil moisture sensor data. Of course, the upper 10 centimeter data was used here. So we also tested to measure, let's say, the soil moisture directly with SAIRs. Of course, we use several machine learning approaches. Here I listed only just some. I mentioned this because these are still field scale, but we were trying to expand this for regional scale, because here in Hungary we have our national directorate responsible for drought monitoring system, and we have very large data available for everybody can reach it, and it is publicly available, even soil moisture data as well, along with agro meteorological data. Some aspects from the drones and UAV data sets. One of our studies related to the upscaling and downscaling issues, combining the drone and satellite data, or even amending them each other, because the problem with the satellite data is the cloud cover, and the problem with drone data is the flight campaign. So it is more costly, of course, than a freely available satellite data. There you can see some results from the LiDAR data, where the biomass can be exactly even the plant height, and later we are planning to estimate not only the plant height, but also maybe the leaf area and leaf area index of the site. And of course, since these are spatial data, those can also be used for precision irrigation. And here in the middle, you can see the thermographic maps, corn, in a case of irrigated and unirrigated patches. The irrigated is blue, the unirrigated is, of course, possesses much higher temperatures, and some relations between. Based on hyperspectral sensor, although these are laboratory scale hyperspectral sensors, but those are also very important I think, sensors in order to develop plant-specific indexes, because we found that there are several vegetation indexes are available to identify and to define the chlorophyll and carotene content. But for instance, for maize or for apple, those are not working the best. And we were trying to find out some new indexes, both either for chlorophyll and carotene for apple and maize as well. We used principal component analysis just in order to select the most sensitive reflectances that can be used to build a new index. And we also used not only just 2 bands, but three bands indexes, because those are more reliable. And we made not only the indexing and indexes, but also we were trying to utilize these indexing together with integrating the raw spectral features as well, using machine learning algorithms just to find the best solution for this. Here you can see some other results related to this. If our new indexing system seemed to be the best, along with the red edge position. I have to declare this, but there were several other indexes which are not as good as our brand new ones. I was talking a lot about field scale and some regional scale examples, especially regional scale for yield estimation. But one of our PhD students are also working on hydrological modeling in Mike, and not just hydrological modeling from the aspect of water governance, in order to provide enough irrigation water for the irrigated site. But also we're trying to expand our results to larger area, and for the extension or expansion of our models, the prerequisite is to know where and what is grown. Therefore, using the year of 2018 and 2022, as far as I remember, these 2 years data of crop area, we developed a machine learning based model for crop cover mapping and identification system. Because if we know where is the corn, we can use our previously identified and found models. It is not closely correlated to the irrigation, but I wanted to also express that in the previous some years, we developed an aeroponic system in climate rooms where all the conditions from light intensity and even the spectral features, and so everything is a climate, I mean, temperature, relative humidity can be controlled. And we tested several other plants for water, food, energy nexus point. And I think these are also related to the smart farming and smart irrigation. However, these are not just irrigation itself, but since it is a very water safe technology, However, it is a bit energy intensive, but can be a solution in those sites where the water is very, very limited factor in planting. There you can see we were producing potato. However, these potatoes are for sowing, and many other plants. There you can see some aromatic plants, but we tested, of course, the general lettuce and so forth. And it is an aeroponic system, so the roots are hanging, and we're adding or spraying the nutrients and the water directly to the roots. And another aspect that I think it is also crucial, because I mentioned you that in the case of places where the water resources are shrinking and not available, especially in the vegetation, or less available in the vegetation period, the reservoirs and the planning, and of course after the monitoring of this reservoir, sedimentations, for instance, are strictly important. And especially the sedimentation can be easily done with these unmanned equipments, and the topology of the lake beds can be, or reservoir beds can also be easily surveyed. And based on these data, based on the hydraulic conductivity of the surroundings, other hydrological models can be developed for ET or infiltration estimation. This is just a reservoir very near here to this university. And as a summary, I put this image here, and I tried to use the AI here in this slide to create this image based on the previous slides that you could see. And I can say that it summarized quite well on my whole presentation, and maybe those most important sensor and model information as well that is strictly required for an optimized irrigation and for a variable rate irrigation in order to optimize our water resources. And special thanks for your attention. And this image is coming from last January. This is a dried lake, and I can tell you that nowadays it is fully empty and it is covered by weeds. So we are hoping to have a bit more circumstances in the future concerning the precipitation. So thank you again for listening.
Thank you, Professor, for the wonderful presentation. I will request you to take up some questions from your chat box or question answer box.
Okay, I'm checking it. Mm-hmm. In the chat, or there is something in the Q&A as well. I will check it. No. No sound. So the first one is, in India, a significant amount of irrigation water is being lost in canal command area. The pressurized piped irrigation may serve the purpose of saving huge lost water. Will it possible to implement sensor-based irrigation system in major irrigation project in India and use precisely the available water? I think it can be possible, but of course, the problem here, as I can see, is, let's say, the huge water loss in the canal. So these canals or channels should be at least insulated. So for instance, in that case study site, which I showed you, the central canal for the lateral moving irrigation system was or is insulated with this HDPE foil. Even the reservoirs are insulated with HDPE foils, and as far as, yes, they have 4 reservoirs already, and out of these 4, 3 are covered with these bows on the top in order to significantly reduce the evapotranspiration, the evaporation of the lake. So these are important technological aspects, and how we can sensor this. In my opinion, there are several sensors are available with which we can measure the water level in these reservoirs, and even with normal water meters, we can also, with telemetry, we can also measure the irrigation water, which was just directly utilized by the irrigation machine. However, I have to tell you that in Hungary, we are also facing with this type of problems, that the farmers often, in many cases, doesn't have these water sensors or water meter sensors. And their water utilization is often based on their declaration to the water directorate. So it is a problem, and I think there is a need from governmental how to say governmental level to give some incentives just in order to solve this issue. The other one, can we use CropWatt version 8 for irrigating field crops in irrigation command, where large variation of soil moisture storage capacity and various types of seasonal and annual crops exists? Yes, it is a very good question, because everybody knows the CropWatt, it's quite robust. So we can add one soil type, we can add the agrometeorological conditions. So I think CropWatt itself is not the best solution for variable rate irrigation, because it can hardly handle the soil patterns and even the spatiality. Of course, we can run separate CropWatt models for separate soil types, but this is the reason why we decided to build this model based on the plant, because the plant, and based on the vegetation index, we can see how the plants develops. And this doesn't mean that I have to put more water where I saw that the biomass is lower. We have to adjust the amount of the water. Maybe we can put less, because, of course, the farmer is the best in this, to know where are those spots on their field which are mainly clay soil, maybe with very bad water holding capacities. I don't know if I'm satisfying all the questions. Dr. Rama, thank you for your words. And yes, I will give you my presentation in PDF, or we will discuss later how it is possible to or I already forwarded to the organizers. I would like to ask about research outputs that were employed by the farmers, and what is the information that was provided? That was provided farmers, and how it was provided? Okay, so we provided them at that 2021 the prescription maps, and as far as I know, they utilized it, and they were irrigating in accordance. However, we got quite small feedback on this. But what is important that on the irrigated area, they get much more yields than in an unirrigated one. They are producing corn and for cattle, so silage is the main cropping focus. Will it be helpful in conservation of irrigation water if we measure productivity in terms of kilogram of water applied instead of kilogram per unit of area? I don't understand totally the question, but yes, the productivity, but maybe the crop water use efficiency is also an important parameter that we need to measure. But of course, often the water use efficiency is not, it doesn't mean that the the crop is using less water. In general, when we are talking about irrigation, I think the best if we are considering not only the kilogram per unit, but I mean with the increase of yield at the site due to the irrigation, but we need to consider the profitability as well, because the irrigation cannot serve only reaching higher and higher yield, because it costs a lot to reach not only the irrigation water itself, but as I mentioned, all the agrotechnological aspects. So yes, this kilogram per unit in itself is not always the best measurement to define our or the success of the farmer. And there is another one from Mobitech: via a solution to reduce the water scarcity. Why can't you go with irrigation automation systems, as you can use an autonomous irrigation system by using micro irrigation gateway of automation sensor-based water supply and so on? Any idea of this about this smart irrigation automation systems? Okay, I totally agree that in the case of micro irrigation, these automatic systems are the best, because everything can be very well measured and controlled. In Hungary, of course, this micro irrigation is mainly focusing on and mainly used, in orchards and in vegetables. But just as an information for you, nowadays they are testing here in Hungary as well micro irrigation, drip irrigation in the case of corn as well. And I also know research not made by the University of Debrecen, but one of the partner of the University of Debrecen, who is testing this subsurface irrigation system for corn. And there's another one, this Q&A session or Q&A part. First one, thanks for the opportunity. Okay, this was just about the recorded presentation. Other one, can we know the amount of water lost as infiltration from water source to crop field if we know soil infiltration rate? If this question is related to the deep percolation, maybe, I would say that if we integrate these data in a physical based model, we can give the deep, we can get the deep percolation, since hydros will calculate it. And we also calculated it for 2020 and 2021. So my answer for this is yes. To calculate the infiltration in canals, it is also an option, since we need to know the water level and the type of the soil in which the canal is, or in the type of the soil of the canal in which the water is flowing. The Mobitech is the same as it was in the chat. I need your email, ID, and contact number for further discussion in future. Okay. I'm just typing my email address to the chat. Okay. Okay. I hope that I answered all the questions. If any other questions, just raise it.
Thank you, Professor. I think most of the questions you have answered. And if there is any other question from the participants, I will request them to write to the professor through email, so you can get the answers. And now I will thank Professor Attila Nagy for the wonderful presentation, very insightful. It was very, very comprehensive, and for sparing the time for giving this presentation, especially from your busy schedule. And I will thank all the participants also who have joined here for this presentation, listening to this presentation. And I will remind them that our next webinar will be in July, and it will be on 24th of July. And yes, the next month we will be having the conference. Those who are in India or those who wants to travel to India soon, so they are all invited to join the conference, Indo-Global Irrigation Summit, which will be held in New Delhi on 24th and 25th of June. And the theme of the conference is the same, smart irrigation management. So, next. Yeah. So once again, I thank Professor Attila Nagy for. We are grateful to you for your presentation, and
it was a pleasure for me as well.
Yeah, we hope to see you in Marseille now. We were expecting you in New Delhi, but I'm sorry that perhaps we communicated with HUSID a little late. So the time period was short. And even if some people, some members of HUSID can manage to come to New Delhi, we will be delighted to have them.
Okay. Thank you so much for the opportunity to present here, and thank you for your kind invitation and your host. So if not earlier, see you in Marseille in person.
Thank you. Thank you, Professor. Bye-bye. Goodbye.
Bye, everybody.
Bye.